Okay, everybody, we're gonna get started. Just in terms of announcements, if I forget to start the video at the beginning of class, you are more than free to yell out "start the video," so that I remember to do that, so that you guys have access to these recordings. Because if I don't start it, then you don't have it. Quick poll: how many of you guys are actually using Git in this course? If you're not using Git, consider using Git. Right? Anytime you're like, I want to add some stuff or make some changes, commit to your current branch, make a new branch, go try out your new ideas. If they're good, great, merge them back in. If they're not, toss away the branch and you can get rid of it, right? This is going to allow you to have multiple versions of your program so that if you want to try out things, you're free to do it, but you'll never lose the code that's still working and you know is good. So consider using that to help make your life easier. We are going to pick up from where we left off on Wednesday, and we're going to add some, fill in the members for the class that we went to go create the other day, right? So we have our string class over here, and we want to go create, starting with our constructors, and then once we have our constructors done, we'll do our destructor, so you get an idea of what the purpose of these things is for, and then we'll go and we'll fill in these other functions that we have here. Does that make sense? So first thing that we're going to do is we're going to create our default constructor. This is our constructor when we get no arguments. So if we get no arguments, what does it make sense to represent in terms of a string? Say an empty string, right? So remember, we have contents and we have len, and so we need to initialize those to be something. So what should we initialize contents to? Remember, it's that pointer. No, null pointer. Well, we could do the empty string, but for right now, we're going to do the null pointer. And then what should our length be? 0. And so all I'm doing right here is I'm calling the constructors for contents and the constructors for len with the ones that take a single argument. Contents has a constructor that takes an argument to a pointer, and it sets it equal to that pointer. So contents is equal to null pointer, and len is equal to 0. Any questions here? Doesn't seem too crazy, right? Should be pretty easy. Now we want to go we'll start with this guy first. So here we want to create our instance of a string class, but we want to create it from a C string. So what do we need to do over here? Well, if we're going to copy the string, we have to have some place to copy it to. So we need to make the space first. So over here, we have two different options for what we could use to make space. We could either use malloc or we could use new. New has the advantage in that the space it creates, it will be initialized by calling the default constructor, which is great. The downside of new is that it cannot be resized. If we ever want to add things or insert things, it's not so easy. The downside of the upside of malloc is that we can resize the space by using realloc. The downside of malloc is that it will not call constructors, right? And so that's really important, and that just makes the space and doesn't initialize it, whereas new will create the space and initialize it based on the default constructor. Or if you make a space for one element, whatever constructor it is that you call. So here we're only working with basic types characters, so it's probably okay to use malloc because we can make sure to explicitly initialize that space later on. So do you guys want to use new? See how it works? Which is a good idea, right? Or do you want to use malloc? We'll use new then, right? And then we also do need, as was mentioned, we need to find the length. So what can we use to find the length of our string? strlen, right? But strlen is inside C string, right? So over here, we're going to initialize len to be the strlen of C string, right? And it's probably complaining about, no, that's fine. So we've initialized len, and then the other thing that we need to do is that we need to create space. So we'd say contents equals new. Well, how much space do we need? Oops, new r n. So I don't know why I put 10 there. Len. Len 10, I think it's because it rhymed. So we make our new space here. This make sense? Any questions? So when we have to resize, we might have some work cut out for us later on. Now let's say the next one that we want to make is our copy constructor. We'll actually do this one first because it's kind of clever. So now we want to create a string from a standard string. So what we could do is pretty much kind of like do the same piece of code that we did up here, but we more or less want to do the exact same thing, so we should call that code by using a function. So what you can do here is we can call a constructor up here in the initializer list. Just 1 second, Noah. We can call a constructor here from the initializer list. And what we can do is we can call this constructor, but we can get the C string from the standard string. So orig.c underscore string. So we get C strings. Oops, this is what? How does that create a delegation cycle? Oh, well, we'll get to that. I'm confused on why it's complaining here, but your question? For len, but we didn't copy the characters over? Yeah, sure. Contents at I is equal to C string at I. They're saying, I think I have to do this to make this not complain at me anymore. Oh, a couple of things we need to fix up here. This should be a const char pointer. We're not planning on changing anything. And this should be a const std : string reference origin. Const char pointer const std : string reference. I wonder if this gets rid of our complaints over here. Okay. Now all is good. And then finally, we're going to do our copy constructor, which is this guy up here. Put him back where it kind of belongs. So now we want to make a copy of the original string into ourselves. So how would we go about doing that? I guess I should pause because this was kind of complicated. Do you guys have any questions here about this constructor? You can call up, well, I guess it's technically possible you can call multiple constructors here if you had multiple parents. But do you guys have any questions about me using this constructor to call this constructor, or inside my string type constructor, I'm going to call the const char pointer string constructor and have it initialize the space for me on my behalf? I'm saying instead of running my code, go run this code instead for the initialization. So then how would I make a copy of another string class? Yeah. So if you wanted to do that right, it'd be like contents orig.contents and then len orig.len, right? Initialize my parameters based on the other person's parameters, right? Instead of doing the assignment on the inside, this is the preferred way of doing it. But does anybody notice any issues with this? Yeah. Yeah, so the issue is now my copy is now pointing to the same location in memory as the original string. So instead of having a copy of all those characters, I only copied the pointer. So now, as was said, any edits made to the first string will also be reflected in the second string as well, and we don't want that. And this is the type of the constructor that the default constructor written by the compiler would make, and you'd have this issue, which is kind of why we need to override it. So I can still set my length equal to the original's length, but then I kind of need to do, this portion again, but not cstring. It's orig.contents at I. So here, notice that contents, right? It's a private member variable, but I'm still able to access that private member variable because I'm still inside the class, right? I'm able to access orig.contents because I'm still inside the class. I guess we need to get rid of this stuff here. Well, I agree. We defined a lot of classes that we didn't implement, which is what that's complaining about. Any questions here about creating a copy? And then finally, we now have all of our constructors, so we need to implement. Why is this complaining? Okay, never mind. So we need to go implement our destructor. So the destructor's job is to release the space that's been dynamically allocated by this object, or do anything else that you want to do when this thing is destroyed. In this case, we're going to make sure that we free up the memory so that we don't have any memory leaks. So how do I get rid of my memory? Yeah, but you don't use free anymore. We use delete, and we have to use bracket delete contents because we made space for an array. And then we could also say like len is equal to 0. It's not going to do anything because this thing is not going to exist anymore, but we can just do it for good programming practices anyway to see that the string was initialized. Or if you want even better programming practice, you set it equal to something funny, so that if you ever see negative 87, it means, oh, I was accessing that thing and it was already destroyed, and now I kind of know. Whereas 0, that makes sense. And then here we should also say, contents is equal to a null pointer. Also, we should only delete the space if there was space allocated. So only if contents should we delete the contents. This check up here is checking to see that the contents is not equal to the null pointer. The same thing as saying contents doesn't equal null pointer. Then go ahead and delete it. Because if it's equal to a null pointer, we shouldn't try to go delete the area pointed to by the null pointer, otherwise we'll get into trouble. Does that make sense? Do you guys have any more questions on constructors or destructors? About what their role is or how to write them? Okay then, we'll carry on. So one of the things that you guys wanted to do is, let's start with the easy one. We'll start with things are equal or not. So how can we check if the characters in two strings are the same, right? I mean, if these two strings are the same. Right, so you might say, if my length doesn't equal the right-hand side's length, we can just return false, right? Otherwise, we're going to need to check the individual elements, right? So for I equals 0, I less than len, plus plus I, if my contents at I do not equal to the right-hand side's contents at I, return false. And if we get all the way to the end, we can return true. Yeah. But we checked up right here that the lengths have to be equal, right? If the lengths aren't equal, we've already gone out of here. So we're only going to go into this else statement if the lengths are equal, so I can use either length because they have the exact same value. So we should be safe here, unless I'm missing something. Any questions here? Yeah. No, the else is not exactly necessary here because you're right. If the if statement holds true, we already would have left. But putting it in there doesn't hurt either. Have the exact same behavior. Good question. So the second const means I will not modify myself when you call this function. I will not modify this instance of the object. So notice in here, I do not change len, or I do not change contents. This arrow len, this arrow contents, I do not change. That's what the const means. That means I promise not to change myself. Right? This const right here means I'm not planning on changing any of the members inside right-hand side. Right? So I'm not changing the right-hand side's length or the right-hand side's contents. And I don't. And remember, like, instead of saying len, we can say like this arrow len. It's the exact same thing, but it's just more writing for me. So if you just say your member variable, you're talking about this is member variable. This is len. This is contents. If I just say len or contents inside of this function or inside any class member function. Any other questions? Yeah. So if you have an argument that has the same name as a member variable, and you want to disambiguate between the argument and the member variable, you have to do this arrow member variable name to access your member. If you just say the argument name, it's only going to change the argument's value. For example, like if up here, back in the constructor, well, you don't have any examples of anybody taking in a length as a constructor. But let's say we go and we add in another constructor over here. So we have string class const char val const int len. Don't save delete. So now maybe we want to be able to create a string that's this value repeated that many times. Right? So over here, I might say, you know, again, my len is equal to len. Now down here, if I say len, I'm talking about the argument. If I say this arrow len, I'm talking about my length. Does that make sense? Yeah. And then here, we'll finish doing this. So contents equals new char len. And then for int I equals 0, I less than len. Again, they had the same value, so it doesn't matter that I'm referring to my argument len as opposed to my member variable len, right? This is member variable len. This is argument len. Contents at I is equal to the value. Any more questions? Okay, so let's go try implementing this static r equal function. Any guesses as to what we could do here? Yeah, so right, so we could just say like return left-hand side dot is equal right-hand side. Right, reuse that code. Any questions here? You can change how the operators equals behaves, and we will discuss later in the class how you can overload these operators to get different behavior. Anything else? Okay. So now you guys wanted to do an append function. But we might as well make something that's just as fun and we'll reuse it. Void insert. We want a... Do you guys want to take in a string or just a character to insert? Or do you want to do both? Okay, so let's just start with the character one first, and then we'll move on to shoving in an entire string inside of ourselves at some arbitrary position. Well, the string one is going to make space for like, the problem is that with typing, I have to get like a string of the thing first if I want to be able to call the function. But I guess I could if I make it so that this thing accepts a string class. So we'll do it that way. So here we're going to take in a const string class reference called toAdd, and then we're going to take in a const int pause. Or do you guys want it the other way around? Does anybody want it the other way around? Okay. So the goal of this function for inserting, it's going to add this string at this position inside of ourselves. We're probably going to have to change our size. So what should the first thing that we do be here? So we need to make space for this new thing, right? Well, that's pretty easy, right? I know how big I am. I know how big that new string is. So my total space should be the sum of those two. So we might have a char pointer new stir equals new char my length plus toAdds dot length. And one thing that I want to change here is I want to, because I don't like that, code generate definitions, not generate definitions, code generate. I want to get a getter so that I can have more control over on. I want to get a getter for length. So I could write this code myself, or I can have the compiler write it for me, and all it does is it returns the length. Not getLen. Because I probably shouldn't be accessing these things directly. I think I used the not getLen. I don't think I refer to the other guy's len anywhere else directly. Okay, so I made space. That was step one. I haven't used it yet. Or, you know, oh no, wait, no, never mind. We want to do it this way. So, well, we'll get to that, but if we delete the old string right away, how are we going to have the contents of the old string to put into our new string? Correct. The first thing that we need to do is copy over the characters from the beginning of our string up until position in, from our old string into our new string. So that's pretty easy. For int I equals 0, I less than pause. Right, new stir at I is equal to contents at I. And we probably want to need to save wherever it is that we left off. Oh, we could use position for that, true. Okay, so we copy over everything before the insert position. And you know, even though like this should seem straightforward, it's probably, you know, getting a little bit more complicated at this point, right? So we probably want to start adding the comments about what's going on. Okay, so we've copied up everything before the new position. Now what should we do? right? We should copy over the contents of the string that we want to add. So for I equals 0, I less than to add dot get length, new string at pos plus I is equal to add dot contents at I, right? So copy in the old, or copy in the new string, and then what do we have to do? Copy whatever happens to be left over. So for I equals, what do we want to start I at? Well, pause potentially I less than our length, right? Now new string at, yeah, the position plus, well, but yeah, to add dot get length, I think is about right. It might be off by 1. Plus I. I know, right? So, you know what's a good thing to do if you're starting to get a headache thinking about things? Well, not do quit, but a lot of times what I find really helpful is you do an example, right? If we have some example that we can actually work our own way through, we can figure out what we're doing, and then we can have the program do the exact same thing. Well, again, let's put an example on the screen and see if we're doing things correctly, right? So maybe like our original string is Catman, right? And the string that we're trying to insert is, so right, Catman dot insert, and we're trying to insert dog at position 0, 1, 2, 3. So the effect of this should be to change it into cat dog man, like man bear pig sort of. So we have, this is what our goal should be from this command, right? And what's really helpful is if we also write up here our indices. So 0, and we'll put a little bit of spaces in here just to give some visual distinction, but the spaces aren't actually stored. So the first thing that we did is we copied over into our new string, right? We copied over cat because we wanted to copy everything less than position. So our new string after the first copy is cat, right? And pos is still 3, right? The next thing that we do is we try to copy over dog, who's at length 3, right? And we're going to start at pos plus I. So we're going to start at 3 plus 0, 3, and then do 3 things. So we're going to get cat, dog. Right? And so now we need to figure out where do we want to start at, right? Our next character we should be inserting should be at position 6, right? So the position that we tried to insert in was at position 3, right? The length of this first string was 3. 3 plus 3 gives us 6, right? So it makes sense to start at pos plus 2 add dot get length, right? The position 3 plus our length 3, 6, right? And even if it was like dogs, right, that would put us over at the right position. Oh, okay. Oh, okay, yes. So we can, yeah, we can set I equal to 0 here. That makes sense. Oh, okay, okay. Right? That should probably work. I need to add a semicolon where? I have to assign it to something. Right? And this should be equal to our contents at I think it's probably I, because we started at pause, right? So again, we want to start at the M in man. So I makes sense. We want to start at pause. Copy over the leftover portion of our original string. Now we also need to make sure that we update our length. So our length should now be equal to, or yeah, we can just add into our length the to add dot get length, right? And then we also need to go delete our original. So delete bracket our contents, and then we need to make our contents equal to string. Yeah, Eric. But we're not destroying ourselves. We're updating ourselves. We're not modifying the string that's being added in, but notice we don't have a const here because we are changing ourselves. Does this make sense? You guys have any questions? Yes. Why don't we create a function called getContent? We probably should, and we have to create two different versions of getContents. We'd have to create a const version and a non-const version, depending on if you want somebody to be able to modify it or not. Or the other thing that we could do is we may not want somebody to be able to modify our contents directly, so we can make that member function private. If we go back over here, I was okay with people being able to, where's get length? Right here, get len. So I was okay with people being able to get my length, so that's why it's public. If I don't want people to be able to get my contents, but I still want to provide a getter for it, which I agree, probably a good idea sometimes. But I don't know if we have time because we only have like 10 minutes left. So we'll skip that. You can go and add it down here. Do you guys have any questions on insert? Delete the old stuff. We got bigger. Set our contents to be the new stuff. Cool. Okay. Yeah. Oh, yeah, this getLen right here, that's my getLen. So if I do, it's the same thing as saying this arrow getLen. One other thing that we might want to do, and I'll go back here for a second and update it, is we could write a separate constructor that just takes in a single character, or we could make it work with this constructor by setting it to have a default value of 1. And when you set default values, they only go in the header file. They don't go into the .cpp. So here now, on line 15, I've actually made 2 different constructors. One that takes 2 arguments and one that takes 1 argument. Does that make sense? So now you guys wanted to have an insert function where we could add in just a single character. And now that we have a constructor that can build a value from just a single character, we can call our constructor and then pass that on over to our other insert. So void insert const char to add const int position. And we're still changing ourselves. Yeah, Eric? Yeah, so we can call it with a character and some number, like take the character z and repeat it 10 times, you get z, 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 z. Or you can just call it with, I want to create a new string with just like A, and then it's just going to be default to the length of 1, just be A. So now over here, because we're lazy, and if you're a good programmer, you embrace at least some amount of laziness in your life. But you work hard now so you can be lazy later. So what we can do is I can do toAdd, and again, I'm calling, not toAdd, insert. Again, at this point, I'm calling my insert, so this insert. And what I can do here is I can just say toAdd pause. But over here, because that's probably going to create a cyclic infinite cycle where I keep calling myself over and over and over again, I can do string class toAdd, and I'll call the other one. So right here, to break it down, I have a string class temp toAdd, and then I'm calling my function with this temp. So I create a new instance of a string class called temp, and then I go and I call this function up here, right? Because this function accepts a string class, and I just made one. Then after this function's over, it'll go delete it, right? Because we've gone out of scope, so temp gets deleted afterwards. Any questions here? Yeah. It will automatically call the destructor, and we'll go and we'll free up that space that we made to hold that one character here. Any other questions? Yes.
Unexpectedly running right.
Base is not released because the destructors weren't called. Okay. So now again, we're lazy. We just got. Oh, what the heck did I just do? Just wanted to grab append. So now we want to add some other string onto the end of our cells, right? Oh, don't delete. Oh, okay. Guess it's back over here. So how could we write this function? Insert at the end, right? So we just say like, I want to insert, and I want to insert, the string to add, and then how would I say at the end? Woo. Right? And if we also wanted to be able to insert a character, right, it's just not too hard. We can just keep reusing all of our old code because we're lazy and we don't like rewriting these things. Char toAdd. So, I don't know why it's invisible. So then over here, I would just say like insert string class char toAdd. Oh no, we wouldn't even say insert. We just say append. Great. Any questions? Okay. Yes. Yeah, so this will create me an instance with whatever that character is. That then gets passed to append. The function then ends. There's nothing to hold in this guy. He gets deleted afterwards. And his destructor will be called. The other thing that you guys said that you wanted to be able to do was you wanted to be able to write substrings. And again, probably one of these things that we could do is, this substring function could probably call this substring function so that we have less work to do. So how do we do this? So we could make a new substring class to hold the substring, and then we could keep appending the characters over. That works. But there's probably like better ways, because that's going to require like multiple resizes and deletions, right, to make that happen. We probably could like allocate len things first and then copy it over. But what is substring sounding a lot like right now? Right? It's in a lot of ways, to me, it's kind of sound like a constructor, right? Because I'm making a whole new thing based on some other information. So we could go write a constructor that also does the same thing, but then also provide like a nicer interface to it called substring to call that function. So we'll go add one more constructor. String class const string class reference, you want to call it like string class reference orig const int start const int len. Go throw this guy up here with our other constructors. Unfortunately, there's nothing inside cline to like have it auto organize. I'm sad. Oh, oops, I copied the wrong thing. Okay, so we could do things that let us get very cheeky here, but we won't get too cheeky with it. Like, we could do things like take the original is constant, so we can't like change its length. But like, there's stupid things we could do to make this involve writing less code, but it's probably not so clear. So what should we do here? So we should probably initialize our length again up here to be equal to len. That's how many characters we're going to end up with. Then we need to dynamically allocate memory, so our contents are equal to new char len big. And then we could do for int I equals 0, I less than start, plus plus I. So yeah, I equals start, I less than start plus len. That makes sense, right? But then we also need something to reference inside of ourselves. So we might have something like int I equals start, cur pause equals 0, plus plus I, plus plus cur pause. Content at cur pause is equal to orig dot contents at I. I mean, you could do like I minus start, and that would work too, or we could just do another variable. Some things that we should probably like watch out for here, and we'll probably get to later, is we should probably like be double checking that this is like legal. That if the user is like trying to copy 100 characters or something that's like 10 long, they can't do that, right? But that kind of like involves exceptions, which we'll get to later in the course, and you could throw some exception when they were trying to do this. But you're not supposed to throw exceptions inside your constructors. So over down here now at substring, we can return string class of who? Who do you want to make a substring of? ourselves. So how do we pass in ourselves? It's almost this. It's see this, star this, because we need to pass in a reference, and then just start and len. Right, and notice we're referring to this len, not our len here. And then finally, if we want to be able to get a substring from just from wherever we start to the end, right, we can say star this, start get len. Right, because it's art. Well, actually, get len is not right. It's get len minus start, I think. If I wanted to copy the first two characters of cat, cat's 3. 3 minus 2 is others. So I want to copy from 0, from 1. 1 minus 3 is 2. That's good. 1 and 2. So get len minus start. Right? Just trying to make sure that we're not off by some indices. And now we have this going. Do you guys have any questions about all this? I guess we can do that too. Yes. No, there is an insert function for real strings. This is our string class, right? I wanted to do something that was like easy for you guys to understand conceptually, but also allowed us to exercise a lot of the features that we discussed. But yes, the regular string class, you can just insert and it works. Yeah, in the back. Oh, any other questions? Well, what about using it? Right, we built all this fancy stuff. We might want to try using it. The other thing that we might want is we might want the ability to like print ourselves, sort of, or what we might also want. Well, we'll just print ourselves because that's simpler. No, void print self. IO stream. We are going to take in an std : o stream reference called out. So you've seen cout a little bit, right? That's how we've printed things to the screen before. Cout is a particular instance of an out stream, which is just something that you can write characters to. So why did that not pass in its argument? Yeah, I know it's not implemented. It's because you didn't copy over the definition correctly. So what we can do is if we pass in cout, for example, we'll write to the screen. But we'll talk about next week, there are things that are like file streams. So this function would also work for a file for printing ourselves to a file. I got 2 minutes. Hold on. So for I equals 0, I less than, get len, right? Just do out, error, contents at I. Not complicated. Just keep writing to the stream to get everything out there. And then, so over here, if we wanted to like create some instances, here's an instance called Matthew. Here's an instance called clone. And we could say something like me dot print self. And then std : cout. And then we'll also std : cout a new line. Oh, it's end line. Oh, end line, yes. And I don't know how I can forget that. And then finally, we might do this again, but we might do it on the clone. And hopefully we compile, fingers crossed. No seg faults? Woo! And so on Monday, we'll try out a couple more of these functions just to show them demoing. And we'll also talk about files. And then we'll also talk about virtual inheritance, or polymorphism and virtual inheritance, or virtual functions, polymorphism, and inheritance. Those are the major concepts, yeah. So maybe you guys have questions or you want to read more stuff. Say it again? Unfortunately, I will be writing your your next homework assignment this weekend, so no, I won't be. Oh, one second. Let me stop this.